My name's Christine and I'm the training officer for AESSEAL. And what we're going to look at today is a subject which is mechanical seals, a fuse in the system. Now time today is a little bit short, so if you've got any questions, please wait till the end because we haven't got time to answer as we're going through. But we've also got a stand on here on M11H, so if you want to come and see me afterwards to talk about some more stuff, I've got more time over there. Okay? Okay, fantastic. Okay, so why do I say a mechanical seal is a fuse in a system? Well, if you look at any piece of rotating equipment, and most of the time we're dealing with pumps, we have 4 sealing areas that we've got to look after. We've got the suction flange, we've got the discharge flange, usually the case gasket, back cover gasket kind of thing, and our mechanical seal shaft. Now, if we look at the suction and discharge flanges are usually this kind of width, multiple bolts in place to hold them down, and everybody tightens them up really nice and tight. In fact, even sticks tubes on the end of the spanners to make sure that they're properly tight. So we've got quite a lot of hydrostatic force sealing a very, very wide surface area. Back cover gaskets, slightly different issue. Back cover gaskets tend to be, what, 8-10 millimeters wide, say. But there again, I'm holding that in place with multiple bolts. And usually 10, 12, 16, 18 bolts to hold it in place. So even though the surface area was narrower, the amount of restraints that I have to hold it in place are far greater, because I need that closing force. A mechanical seal's different. The sealing area of a mechanical seal is only about 3 millimeters, 1/8 of an inch wide, that's all. Now it sees exactly the same fluid that those gaskets do. It sees the same temperature, sees the same pressure. But it's different. And it's different because it's the only sealing member in that piece of equipment that's dynamic. And it's only 3 millimeters wide. So guess what? If there's a fault somewhere else in the system, where do you think you're going to see the leak? You're going to see it in the mechanical seal face. And that's why a mechanical seal is a fuse in the system. But unfortunately, we don't treat it as such. And what I mean by that is, if you were to go home tonight and you think, want a cup of tea? So you go home, you fill the kettle up, plug it in, switch it on. And as you switch it on, it pops the fuse in the plug. What would you do? Question? Put a new fuse in the plug, wouldn't you? Okay. So you put a new fuse in the plug, stick it in, switch it on, switch the kettle on, and now, boom, it pops the fuse in the plug again. Now what do? Yeah, you would now check out the kettle. That, or you say, excuse me, my little love, your wife, can you just hold this down while I just get a cup of tea or put a nail in it or whatever, just to make sure you can get your cup of tea. But the thing is, we don't do that with mechanical seals. You wouldn't have gone and said, well, actually, I bought those fuses from B&Q, and the fuses from B&Q are no good. So I'll tell you what I'm going to do now is, I'm going to go and buy fuses from Homebase, because they're better, and put those in. You wouldn't even think about doing that. But people do it with mechanical seals all the time. They put in a brand of mechanical seal, they put it in, and it doesn't work. So guess what they do? They put another one in. And guess what? That one doesn't work. Does this sound a bit familiar? So now what you do is you say, I know, let's try somebody else. So now you go and buy them from somebody else and you put those in. And guess what? You put a couple of those in and they don't work. And you say, well, they're all garbage, they're no good either. Let's buy somebody else's. They're not. People don't sit there in the morning and say, tell you what we're going to do today. Let's make a really rubbish mechanical seal because we'll make loads of money by selling lots and lots of them. People don't do that. The mechanical seal is a fuse in the system. This is the fuse in your kettle. And if you want this to have good life, you have to treat it like a fuse in the system. Now you have to check out the kettle. And the kettle you're checking out is your piece of rotating equipment. Does that make sense to everybody? This is yes, that's no. Fantastic. Because we have this thing is about how long really should a pump last? Well, we know as an industry that 85% of all pump failures are either mechanical seal or bearing related. And we know that when buyers want to buy new pumps, they expect them to last 25 years before they have to buy a new pump to replace it with, because nobody wants to spend that kind of asset costs. Trouble is, you've also got these issues with bearing reliability on average of being between 2 and 3 years, and you're trying to aim for 5. And more often than not, you can't get that because these things are not working properly. You're blowing the fuses in the system. And guess what you do? If you change the fuse in the system, I'll bet you 9 times out of 10, you put new bearings in it while you've got it in one piece anyway. So if I'm going to put these into a piece of equipment and get good life, what do I need from my piece of equipment in order to get good life out of a mechanical seal? Well, mechanical seals like to be kept cool, just like anything else that wants to give you good life. Mechanical seals need to be kept well lubricated, and the cooler I can keep them, guess what? Just like the engines in your car, the better lubricated that seal face will be. I need to have a clean fluid between the seal faces, because here's the thing, all mechanical seals leak. They have to do in order to work. It's just that the layer of leakage is so low, you can't see it. And if you think about it, if you've got 2 seal faces in a mechanical seal, and you're running silicon carbide against silicon carbide, if they touched each other, they'd just get hot. They wouldn't last very long. I don't allow that to happen. What I do is, I allow a very, very thin layer of lubricating fluid to pass between the two. And when it does, it takes the heat away. If I now allow that lubricant to be dirty, guess what? My mechanical seal won't last very long. Just like your engine in your car wouldn't last very long if you put dirty oil inside your car engine. And I need that lubricating film to be stable. If it isn't, guess what? I've got poor lubrication between my seal faces. And now, as soon as I've got poor lubrication, guess what? I've got poor life expectancy. So this is a fuse in the system. And you need to treat it like it is a fuse in the system. If you're blowing fuses, check out the kettle. And here's the thing, how long should a mechanical seal last? You probably ask your seal suppliers that. How long should a seal last? They should actually last till the seal faces wear out. Because when I make a mechanical seal, I make the seal faces from 2 dissimilar materials. I have a hard face and I have a soft face. Even if I run silicon against silicon or tungsten against tungsten, I use different grades. So I still have a low coefficient of friction. Because if I've got low friction, guess what? I've got a cooler seal face that's better lubricated. So when I take that seal out, I should take it out because the seal face has worn away. But guess what? We repair mechanical seals as a company. And 99% of all the seals we get back for repair, the seal faces are not worn away. They failed for some other reason. And the problem is, we're blowing fuses for some other reason than we've worn the seal faces out. And here's the other thing, something to bear in mind. People that sell these things, this is black magic, voodoo, mumbo jumbo. Actually, they're quite simple things to understand, to be perfectly honest. Mechanical seals only fail for 2 reasons. And the only 2 reasons they fail is either the seal face is open. By open, what I mean is the gap between the 2 seal faces becomes too big. And as soon as it does, now the particles and dirt that's in my liquid can now get between my seal faces and cause damage to the seal faces. Or a part becomes damaged. They're the only 2 reasons a mechanical seal fails. There are lots and lots of things that cause that to happen, but if you understand that as a fundamental practice, that they only fail for those 2 reasons, when you're trying to figure out why these are not working, guess what you have to figure out? why one of those two things has happened. Either the seal faces have opened or a part has become damaged. It now makes your fault finding a simpler product. Does that make sense? And here's my mechanical seal. What I do is, if I've got a single seal, it's called a single seal because I have a single pair of seal faces here. What I do is, these two seal faces want to touch each other. I don't want that to happen. So what I do is, I allow a microscopic layer of liquid to pass between the two. And the layer of that liquid is only 1 micron thick. And here's how it all works. If the gap between those two seal faces is only 1 micron thick, then any lumps, any particles that are inside my fluid, if they're greater than a micron, and most are, now my seal faces act like a sieve. They act like a filter. So they stop those dirty products from getting between the seal faces. Because all mechanical seals leak, and high pressure always goes to low pressure. So if I can keep this gap here stable, and I can have a nice clean fluid between my two sets of seal faces, guess what? My mechanical seal is going to last a long period of time. But unfortunately, what we do, we kill them off before they've actually got to their full life expectancy. So how do we do that? Well, most of the problems come from equipment. A lot of you people, or a lot of industry, runs pumps that are too big for the system. How do we know that? Because you run them with partially closed discharge valves. True? So why do you run them with partially closed discharge valves? Because the pump's putting out too much flow. So now you gag the pump back, you throttle back the discharge valve. But when that pump was sized, it was sized to run at a particular point on the curve, at its best efficiency point, within 10%. Now I start to close down the discharge valve. Now as I do, I start to put radial forces on my impeller. This is called a radial forces diagram, and very rarely do you see that put on a pump curve. But now what starts to happen is, as you start to throttle that pump back because you've got more flow, you change the velocity of the liquid inside the pump because you recirculate it. If you recirculate a liquid and change its velocity, you change its pressure. And a pump is not a hydraulically balanced piece of equipment. So if it doesn't run at its best efficiency point, now you change the hydraulic balance inside here. And as you do, you now impart that hydraulic imbalance on the impeller. And as you run it away from the best efficiency point, now you start to put those forces on. And as you put those forces on, you'll recirculate the liquid inside the case, as I said before. You'll even, if you start to throttle it back enough, not just recirculate inside the case, you'll now actually push it back to suction. Because liquids follow the path of least resistance. So if it's easier for that liquid to travel 100 or 300 millimeters from discharge back to the suction side of the pump rather than going 300 meters up in the air, guess what it'll do? It'll take that shorter path. Now as soon as it does, now I get vortexing at my impeller. If I've got vortexing at my impeller, I've now got instability of the pump shaft and instability of the lubricating liquid fusing my system. I'll start to get reduced impeller life because now I start to bend the pump shaft and the pump impeller now comes into contact with the casing, and now you have to start to replace wear rings. Now I've got vibration occurring, and as soon as I've got vibration, now this drastically affects the life of this, and also now the bearings in my pump as well. And those are the bearings you're spending a fortune on, putting expensive oils in and doing condition monitoring on as well to make sure that they try and last a long time. If I throttle it back enough, now the energy from the motor can't be used. So now that energy from the motor turns itself into the easiest thing it can do. Now it turns itself into heat. And now what I do, I raise the temperature now inside the pump as well. And as soon as I do that, guess what? I change the lubrication for my seal faces. If I run the other way, I think, it doesn't matter really. I'm not going to throttle the pump back. Let's just let it pump anyway. Now my pump puts hydraulic forces on the other way because I'm putting out too much flow. And now if I push that flow enough, I'll get to the stage now where my pump starts to cavitate. We've also got stuff like this, misalignment of equipment. And I know, because my background originally is from maintenance, that we all like to align equipment properly. But sometimes we don't get the opportunities and we don't get the times to do that. Why? Because production rules everything. Downtime is the killer, because that's a cost. So what happens is now somebody somewhere has to cut a corner in order to get that piece of equipment back into service. And if you do, now guess what you're going to do? You're going to put vibration into the equipment, and as soon as you do, you're going to do my seal. Because these only fail for two reasons: either the seal face is open or a part becomes damaged. And if I've got vibration, now my seal faces are opening and those particles can get inside and start to damage the seal faces. Or we have people that run pumps with no fluid in. They pump tanks dry, or they don't open suction valves before they start the equipment up. And now, because mechanical seals are full of things like O-rings, I fry the O-rings in the seal instead, and now the seal's killed. Or for whatever reason, I get no flow through the pump. Somebody's not closed, somebody's not opened a discharge valve. I've got suction strainers or filters in the pump that are becoming blocked. All these things now, as soon as I get no flow through the pump, I now reduce the cooling to this. And these things like to be kept clean, cool, and well lubricated. If you don't, guess what? You ain't going to get good life out of them. We also have vibration too. Cavitation damage if we push our pumps far enough. And sometimes we have pumps that are linked with pipework or sat on mezzanine decks. And this pump here is vibrating away quite nicely, sat connected to the pump next door to it. So guess what we do? We kill the seal in the pump that sat next to it because that one's vibrating. And if we don't kill the seals, what we can quite often do is false Brunel the bearings. We can flatten the bearings in the pump. So the next time we come to start it up, it's got a nice lumpy ride, and the first thing you do is take this sucker out. What you need to have is something. You can't stop some of those things happening because that's what's going to happen. That's real life, isn't it, guys? So if you can't stop things from happening, what you need to do is to put a surge protection device on your system. If you gentlemen and ladies have got computers in your offices or computers at home, I will bet you have some form of an anti-surge device on your computer. True? Yes? Why would you have that? Because you don't want to fry your computer. True? How much does a computer cost? 600-700 quid? How much does a pump cost? Thousands. How much is downtime? Thousands. So we'll protect a £600 computer, yet we won't protect a multi-thousand-pound pump, sealing system and production facility. We'll do things like, say, electrical surge protection devices. We will put safety relief valves on pressure systems, or we'll put burst discs in to prevent us from damaging stuff. Yet we don't do anything for these for when things happen that are beyond my control. But you can buy surge protection devices for mechanical seals. They're called double seals and systems. Now what we do with the double seal is, if I run a single seal, whatever the liquid is I'm pumping, that's what I'm going to use to lubricate my mechanical seal faces, because I have to get a lubricant. Now what I do with a dual seal is, I put two sets of seal faces in, and I put a circulating fluid between the two on an encapsulated system. Now because I've done that, I've now get to choose the lubricating fluid that passes between those seal faces. When I run a single seal, I have to use the product to lubricate my seal faces. I haven't got a choice. So I get a bump in the night, I get those things that change the gap between my seal faces. I can't do anything to stop it. If I put two seals in and circulate a clean, cool compatible liquid between the two, now I do get to choose. Now when those seal faces open, which I can't stop happening, guess what? All that happens now is nice, clean, cool lubricating that I've picked now passes, pardon me, through the seal faces instead. So here's my dual seal. 2 sets of seal faces. I've now got a dirty product in here, and that dirty product wants to get between my seal faces. I don't want that to happen. So what I now do is, I introduce inside a clean, cool lubricating fluid. And now when it does, I pressurize it inside here, so that the pressure inside here is higher than the pressure inside my pump. High pressure goes to low pressure. All seals leak. So now the lubrication fluid that I've chosen now passes between the seal faces, and it's a clean, cool, compatible fluid. If we run single seals, quite often we'll run systems like this. We will run systems either with an external flush line to try and dilute the fluid inside or cool it, or we'll run sealing systems on the atmospheric side of the seal. So as those liquids pass between the seal faces and leave deposits inside the seal, I put a circulating fluid inside that takes those away. But lots of problems with running systems like that. The problems with running systems like that is, I'm going to use a lot of water. And that water is actually going to end up in my effluent system at some stage, or I'm going to have to extract it, and that's all a cost. I have the problems with plant drawing down on that watering main as well, because we have people that wash equipment down. Do you wash equipment down? And when you wash equipment down, the guys don't use 1/2-inch hoses, do they? They use like a 2-inch or 3-inch fire hose, and now they're spraying that stuff around all over the place. And as soon as they do, now they rob that ring main of the fluid that's now controlling your mechanical seals. And we also have environmental issues and health and safety issues with running seals that can leak into atmosphere. Here's something that's interesting now. If you have a leakage rate on one of these seals with a flush line or a quench to drain, which are really, really common, if you have a leakage rate that's as low as 2 gallons a minute, that's the equivalent of 1 million gallons of water per year per seal. And that 1 million gallons of water is either going to end up in your product and you've got to extract it, or it's going to end up in your effluent system, you're going to have to clean it and then dispose of it. 1 million gallons of water a year? Sounds like a lot. Can anybody picture 1 million gallons of water? Bit hard, isn't it? 1 million gallons of water is approximately equivalent of around about 16 road tankers full per month. So if you run pumps with flushes on or quench to drains, that's the amount of water you are leaking and wasting into your product every year. Now, mechanical seal faces leak, and we can calculate how much they leak. And if you look, this is a pump with a seal in it, and pump pressure is 5 bar. The leakage through this seal would be approximately litres an hour. Now, if I've got 2 seal faces on it, guess what? I'm going to leak 0.18 millilitres an hour. That's an easy amount of liquid to picture in your head. 0.18 millilitres an hour. Well, if you're running quench to drains or flush systems, you're using this, 16 road tankers worth a month. If you change over to a dual seal with a seal support system, your leakage rate now is down to less than a teaspoon a day, or less the equivalent of about half a can of Coke a month. So you can either use 16 road tankers of water, or you can use half a can of Coke. I'll leave it up to you to decide which one you'd rather use. So what can we do? Now there have been developments with systems now where we can support multiple seals from dedicated circulation systems. Because now we want to get away from those problems of those dirty ring mains, or those ring mains that get the water pulled down, or we suffer with evacuation problems. What we can actually do now is connect multiple seals into a dedicated seal protection device. Or we can run them on individually pressurised systems too, where each seal is purposely set to its own individual pressure. So some applications I may want to run with positively pressurised seals, or some applications I may want to run with passively pressurised seals. If I run systems like this, and these are the latest developments, I can use this to take more control over the fluid that I'm using to lubricate and supply the fuse in my system. The other problems are, if there's anybody here that's involved with the food and beverage industry, one of the problems we have is bacterial growth in a system. Now, if I run normally a double seal in a system, because all seals leak, I don't want to have high pressure from here, if I pressurised it that way, going into my product, because that would be a potential contaminant. So what I now would choose to do is to choose this as a passive system, where the pressure inside that seal pot is lower than the pressure inside my pump. But the problem is, now if I do that, the product is going to leak through the seal and end up contaminating this support vessel. And that's now a problem, because the temperature in there is going to be between 40 and 60 degrees. And that's a good temperature for growing bugs. And if I'm involved in the food and beverage industry or the pharmaceutical industry, one of the things I don't want to do is to now put the presence of bugs into my system. So guess what I do? I don't run seal support systems like this. I now run systems that run on a quench to drain, and I still chuck all that water down the drain. And for companies like Coca-Cola and the big drinks companies, that's a major problem. What we've actually now been able to develop is vessels that now come in two-halves, because the problem with the old-fashioned standard vessel was I couldn't get inside this to clean it, to make sure that it was clean inside. And what we've actually now developed as a company is a split vessel, where we can even put in the top CIP to inside. Really, you can actually disassemble the vessel and clean it and take it to pieces. We've even put hygienic polished welds in there, so that there's no bug traps and no hiding places for those liquids inside the seals. So why do we want to use dual seals? Well, these are all the disadvantages from me using single seals with those quench to drains and those flushes. The advantage of using a dual seal is that I eliminate all those things. I get rid of all of those problems, all that water wastage, all those health and safety considerations, all those environmental concerns and costs. Plus the fact, the added bonus is, I also overcome all those other problems that those production sides of the business now put on me. Now if I get pumps running dry, guess what? I don't care, because I've now put in a circulating fluid between the two. I don't care if I've got slight bits of vibration inside my seal, because now when those seal faces open, all I'm going to do is allow a nice lubricating fluid to pass between them and to protect my seal. If I've got pumps are running away from their best efficiency point and I'm getting radial deflection, those hydraulic loads, now when that happens and my seal face is open, now all that happens is nice clean fluid passes between the two. What I'm going to do is to protect the fuse in my system. So what's the secret to getting good seal life? Well, the secret to getting good seal life is my seal faces need to have a clean, cool, stable fluid film between the two. And I need to put a fuse protection device on my system. Put dual seals in. It's the only way you will have of increasing your window of operational error. Thank you. If you've got any questions, come and see us at M11H. Thank you very much indeed. Thanks for everybody for your time.